All right, we're back. I think we're kind of on page 57. I don't really know. We spent the last video working out a one-to-one version of sine so that it would be a function that has an inverse that is a function, right? So we worked out that if we limit sine from negative pi over 2 to pi over 2, it covers the entire range of sine, which means that the inverse function will be completely useful because we can do the inverse sine of anything in the range of normal sine, and it'll give us an angle. The angle will always be between negative pi over 2 and pi over 2, but that's okay. That's the convention that everyone agrees on. So what we're going to do in this video is basically the same thing, but for cosine and then for tangent. Then maybe look at the next page, because I think that I basically did that page accidentally. So let's see. So it's going to be the same kind of deal, right? So let's label up the quadrants of the unit circle. So quadrant 1, quadrant 2. This is where it's really important to understand the relationship between the unit circle and the graph of cosine, right? So graph of cosine only cares about theta and the x coordinate on the unit circle. It doesn't care about y, because on the unit circle, cosine is x. And we should have looked at that in another video. I mean, I think we did. I don't know if you were watching it, but 1, 2, 3. So this is all really similar. Once you get the idea down, you can limit your trig functions really quickly based on this idea. But it's so important to understand this idea though, because later on you're going to maybe have trouble remembering some of this. Like when you're really doing the problems, it's easy because you do it so often. But then eventually you kind of forget. Then if you remember how you created it, which I think is easier, look for that one-to-one function. You're going to be fine. So this is the important process that you want to go through. So let me just highlight. These are unit circle quadrants. Mostly I'm doing this so that it looks the same as the sine graph. All right, what should we do? Well, last time we said we're keeping quadrant 1 no matter what happens. So quadrant 1 goes from 0 to pi over 2. So if I keep quadrant 1, because I need to get a one-to-one function, I'm going to have to go through and erase a lot of stuff, right? So just have a horizontal line here. So you can see the horizontal line is going to intersect here, here. All this has to go. And if you imagine moving the line up and down, you can just see. We got to erase everything that's above the axis that is not from quadrant 1. So you got to go. So there we go. Gone. Gonna leave that because we're not really dealing with the negatives yet. Over here, gone. Also shortening my horizontal line that I'm using to test. And then I'm just gonna outright break it here. I'll just delete that. There. And then there. There, okay. So we made it one-to-one above the x-axis. Now we gotta do it below. I feel like when you're looking at this, there's almost only one obvious choice. We would prefer to have a continuous function. So let's just keep this part from pi over 2 to pi, which corresponds to the second quadrant of the unit circle, right? So we're keeping the first quadrant and the second quadrant of the unit circle. Not only that, we're keeping them between 0 and pi, right? For sine, we kept the first and the fourth quadrant, but not the fourth quadrant you're used to. We kept from negative pi over 2 to pi over 2, right? So it's like we started at 0 and we rotated clockwise pi over 2, or we rotated counterclockwise pi over 2. So it's still the first and the fourth quadrants, just not the way you're used to them. So here, it is the way we're used to them. So let's what should we do? Let's finish this, right? So all kinds of problems. We're keeping quadrant 2, we're going pi over 2 to pi. So I'm going to start erasing. So let's erase that. And then here, you're gone because you are not making this a one-to-one function. Or rather, you're screwing up it being a one-to-one function. So here, we actually lose everything. All we're keeping is from 0. So let me put in 0 because it feels like that'd be better. We're just keeping from 0 to pi over 2. We're keeping quadrant 1 and quadrant 2 of the unit circle. So that means that we're keeping, maybe can I, no, I deleted it. All right, let's see. quadrant 1 and 2. So I gotta make a unit circle. You know what I'll try to do? I'm gonna save this so that I can at least do it for tangent. Circle. Circle is like a little too big, but that's okay. All right, so we're keeping quadrant 1 and 2. So now I gotta trace. Here we go. There, there, and then trace it. I have like the least, well, they're not the least steady hands, because I'm sure there's someone out there with less steady hands, but not great. So go away, you. There we go. So what are we keeping here? We're keeping quadrant 1, quadrant 2, specifically from 0 to pi, anything from the top half of the circle. So now you know the inverse cosine of 1/2 has to be the angle between 0 and pi, where cosine is 1/2, so it's got to be pi over 3. Inverse cosine of negative 1/2 is the angle between 0 and pi, where cosine is negative 1/2, right? Where the x coordinate on the unit circle is negative 1/2, which is probably actually more extreme than that. Maybe this, I don't know. Anyway, 2 pi over 3. So this picture, I fall back on the unit circle picture all the time. So what did we make this? This is 1 to 1. And that means the domain, 1 to 1. And the domain that we kept is 0 to pi. And so everyone, am I using theta? No, I'm using x. Everyone agrees that this is the domain that we use for our 1-to-1 graph, which means everyone agrees that the range of inverse cosine is 0 to pi, sorry. So that's the thing, you have to agree, you have to use the standard thing. So you grab a calculator, you evaluate it, it's gonna give you these answers. So it's really important that you kind of recognize that. All right, let's do tangent. Tangent, you can see, is gonna be maybe the easiest one, because tangent sort of wants to be 1 to 1, and then there's just like stamped copies of it everywhere. So this, quadrant 1, quadrant 2, quadrant 3, and this would be quadrant 4, but I didn't even bother to graph there, so that was nice of me. This is quadrant 4, but negative angles. Quadrant 3, but negative. Quadrant 2, but negative. And quadrant 1, where again, I didn't even bother to graph. So you can see, if you look at this graph and you're like, what should I keep? If you're not thinking, well, you got to keep quadrant 1, which means you might as well keep this really nice tangent. Like, you get a really nice tangent on its own. So let's just start erasing. Let's not belabor the point here. So everything must go, basically, except negative pi over 2 to pi over 2. So you keep the asymptotes because they're important. And because this graph has vertical asymptotes, and the vertical asymptotes have equation x equals blah, well, x equals pi over 2 and x equals negative pi over 2, but the key thing is x equals, because the vertical asymptotes of the tangent, the 1-to-1 tangent graph, are x equals, the graph of inverse tangent is going to have horizontal asymptotes at negative pi over 2, at y equals negative pi over 2, and y equals pi over 2, which is why I think it's the coolest of the graphs of the inverses, and it's also like the most important. So 1-to-1, really important, because you get asked a lot, like, what does this graph tend toward as x tends toward infinity or negative infinity? 1-to-1 domain. So the asymptotes are not in the domain, so this is really similar to sine, but it's not the same. Sine counts negative pi over 2 and pi over 2. Inverse tangent is not going to count those. And then, oh, I'm so dumb. I meant to keep that, but I didn't. I was supposed to like copy and paste it. You probably heard me say it, and you're probably like, no, copy and paste it, but I didn't. You know what I could do? I could go up and get the sine one. You know, it crossed my mind, so let me do it. See if I can fix this up and make it work. So I'm going to steal this, duplicate you. Let's go for a ride. Okay, here. Now the difference is, and I don't know how I'm going to erase this, but I'm going to try. The difference, got to use pinpoint accuracy here. I got to get rid of this solid dot. Crud. Yes, and then Okay. The difference between the parts of the unit circle that you save are very minuscule. It's this. Open circle, because you can't have negative pi over 2 or pi over 2. There is no angle, right? Like, you're not going to do the inverse tangent of infinity or the inverse tangent of negative infinity, because, like, what does that even mean? So we don't include those because of the vertical asymptotes, but we've got all the information that we need. So what should we do? Should I, all right, you know what? I'm gonna cut the video here. I'm gonna come back in the next one. I'm gonna copy these graphs though, so you're not gonna have to watch me copy this stuff again. So I will, in the interim, I will copy everything onto this page, all the graphs that I made, and then I will fill in. The key thing here is the oh, there's nothing to fill in here. Yeah, I'm just gonna do it. Just gonna do it. Copy them in. So I'll see you in the next video. I don't know, where we're gonna be doing more stuff. So I will see you there.